Hello and welcome to the Global Passive House Showcase, presented by Passive House Accelerator, a catalyst of zero carbon building. We're happy you're here. We welcome all comers to our exploration of how to slash the greenhouse gas emissions from our buildings and make them more resilient to the extreme temperatures, the wild weather, and the grid insecurity caused by climate change. So, whether you're passive house curious or passive house expert, this is a place to learn the do's and don'ts, the best practices, and the lessons learned of passive house design and construction. We'll dive into how passive house design principles are applied in the real world and how this approach to construction impacts the health and happiness of the people who live and work in these buildings. Are you new to all of this? Visit the Passive House 101 section of our website to get started. With that, please enjoy the showcase and pose your questions in chat for the discussion session after the presentation. Thank you.
All right. Well, welcome everyone to the Global Passive House Showcase. We're really happy you're here. This is our first showcase that we are presenting at a time slot that is friendly to UK and European communities. So we're really excited to be doing this today and to be kicking that off with Anne-Marie Fallon of Archetype. So thank you for being here. Our guest host today is none other than Jessica Grove-Smith. And Jessica, as everybody on the call likely knows, is the Joint Managing Director and Researcher at PHI. She's also the North American Liaison through IFA, and she's a pivotal global figure in the Passive House community. So we're really honored to have her here today to share some thoughts with us and to introduce our speaker. So with that, Jessica, please take it away.
Thanks, Zach, and thanks for inviting me as a co-host to be here as part of this session. Great to be here, amazing. I've always loved the happy hour and really enjoyed joining, but it was very tough for me to stay up until midnight or 1 a.m. in German time zone. So much appreciated that we now have the Global Passive House Showcase at this hour, which is much more reasonable for kind of the European time zone. And I think also plays a really important role in kind of the international networking, exchanging experiences across the pond, so to speak, from the different continents. With so many things happening, I think it's great that we have this opportunity to exchange experiences. I don't really want to spend too much time as a co-host before we go to our highlight, which is Anne-Marie, who I'll introduce in just a second. Two things I briefly want to mention on the topic of international network and exchanging experiences. One, as Zach mentioned, IFA is one of my roles, the International Networking, International Passive House Association, where we bring together the passive house networks, the passive house groups from the different countries. And IFA this year has run a campaign which was called Efficiency First, where we've created a lot of pamphlets, a lot of information, a lot of material, where we've really tried to raise more awareness also outside of the passive house community, how important it is to have efficiency first when we look at sustainable buildings and we want to reach our climate goals. So I'll post a link to that in a chat in a second if you want to have a look at some of those resources. One of those, for example, is to link Passive House to the UN Sustainable Development Goals and how important really efficiency is for sustainability. And the other thing that I can't go without saying today is this week is the week of the International Passive House Conference. And it's an anniversary conference. It's the 25th time that we're running the international conference. It starts Friday. So Friday and Saturday are 2 full days of presentations. Sunday, you get to go on excursions, virtual excursions to visit some projects, and then more presentations next week. So you're still welcome to join. Come along, have a look at those presentations. The opening session on Friday is going to be free for all, and a special highlight of that this year is that we're going to be announcing the winners of this year's International Passive House Award. So again, I'll post a link in the chat in a second, and you're very, very welcome to come and join that event and celebrate with us. 30 years since the very first Passive House was built in Germany, and 25 years since the Passive House Institute was founded and the International Passive House Conference has taken place. And with that, I think I've said enough. I'm going to hand it over to the highlight of today, which is Anne-Marie Fallon. It's great to see you here, Anne-Marie. Anne-Marie is joining us from the UK, Anne-Marie is Associate Director and Certified Passive House Designer at Archetype. And Archetype is a very inspirational architectural firm. For me, I have a lot of love and respect for Anne-Marie and the team at Archetype because they play such a leading role in the passive house community in the UK. They've done a lot of fantastic projects, award-winning projects, very inspirational projects, ranging from new builds, but also retrofit projects. And one of the specialities is schools, which Anne-Marie is here to speak about today. So always a pleasure to work with you, Anne-Marie, and fantastic to see you here. And I'll let you take it away.
Okay. Thank you. I hope I live up to that lovely amount of praise from Jessica. Thanks, Jessica. Okay, so hi everybody. I'm just going to share my screen, and I'm under strict orders from Zach that I have a very short time frame. So I'm going to rattle through a number of slides and placeholders that are probably quite thought-provoking, hopefully, and really looking forward to kind of engaging in the Q&A session afterwards. And if I'm really frank about certain things, I hope that's taken really well later on. So just bear with me, and I will just confirm that you can all see my screen. Right, okay, so Jessica's given us a bit of an introduction to who Archetype are. We're a practice that's been around for about 37 years now. We have 3 bases. Our most recent one was established in Edinburgh in 2018 in response to Scotland's really ambitious climate policy targets that they've set. We also offer a kind of a sister consultancy alongside our architectural services called Perform Plus, which is mainly dealing with building aftercare, building physics, energy modelling, post-occupancy evaluation, etc. And we've been kind of offering it as a service for years, but have kind of identified it as a separate service to the architecture section of the practice in recent times. As Jessica's mentioned, we've spent 15 years now developing passive house non-domestic projects in the UK at varying sizes, aesthetics, locations, and typologies. Here's just a couple on the screen, and today's focus is going to be on schools and school design. And so what underpins a lot of our design is the post-occupancy evaluation we've been carrying out, particularly on our earlier schools, even some of the non-passive house schools at the very beginning, where we actually have a really good track record of that proof of performance, that proof of concept, and that's so important when we are speaking with clients and convincing clients, and particularly in this era now where indoor air quality and health and well-being has become very at the forefront of decision makers' minds. So what does that mean for generally our approach to passive house projects? Well, the very most important element to us, and I'm sure many of you around the table will agree tonight, that the brief and establishing what those requirements are really, really important. And just for those of you across the water, this is a representation of the Reba plan of works, so the architectural plan of works for the UK, the Royal Institute of British Architects. And what we've done quite a bit of work almost beyond this workflow diagram to look at how passive house is incorporated into that workflow, and actually working with Reba and the Passive House Trust in the UK at the moment to really formalise that as an information flow to help architects and help the industry in the UK. And really the critical element of that for us is the post-occupancy, the reflection, and then the redefinition of that. And we might touch on some of those aspects later on in terms of informing that design. Now, of course, in my 15-minute slot today that Zach's timing me avidly on in the corner, there's so many topics and so many areas that we could talk about, but I'm going to focus on a couple of different areas: costs, post-occupancy and air quality, and the typical design approach, and just end with a couple of built case studies and one key study in Scotland that's just under development at the moment. So there's a PhD that we can written on that one page, and we can, welcome to discuss some of those topics afterwards today. So how do we approach passive house design? In that cyclical collaborative relationship that we've established with the workflows of architecture in the UK, we're always looking to seek out the simple form and the reductive form. And again, many of you around the table will want to push that and kind of, implement that on your projects, and have probably been doing so already. And a really simple example of this is a project we're working with in Scotland at the moment that's about to go to site, where the original school was facing east and west. And instead of saying, okay, look, we'll just put the replacement school east and west alongside, we actually pushed the planners and the client to turn the project to a north-south orientation, which helps with passive house keep the form simple as well, but also it gave a connection and it had a sense of architectural place in terms of that simple massing option. Again, on other sites, that drive to try and be within 15 degrees of south, and aware that all over America there's a certain desire or lack of desire to maybe be totally south, because it will, there's very diverse climates across America. So what we're looking at here may not always be representative of the most optimized form for your zone. And looking at that form factor and surface area to volume ratio as much as we can as we design, because as an architect myself, I can say this with gusto, we love complexity. We like adding kind of motifs and kind of symbolism or devices to our design that kind of reflect an alleged ethos. And really the ethos at the moment is the climate emergency, and how does that provoke a response from designers? And really what it should respond is not buildings that are very additive in their design and creating lots of complexity for the contractor to build. We want to create real simplicity. It maybe cannot always be as abstract as the Imperial War Museum here is, the archive that we worked on in near London. But you know, that ethos or that simplicity principle needs to be there. That doesn't mean that we can't have complex forms or larger forms that are east-west facing or H blocks that need to accommodate a client's brief. We just need to be very mindful of how that is driven through design. So on the left, we'll talk about Curry later on, and on the right, that's Harris Academy, something which I'll also touch on briefly. The approach to the glazing, you know, again, as architects, we love to overglaze, and some of our own lessons learned from our own post-occupancy has been about reducing the size of glazing and only using the glazing where it's most useful to us, which is, you know, typically above 800 mil in our part of the world, in the UK, and really having stringent requirements around day venting, day lighting, and night venting as strategies alongside the MDHR solution, and also integrating that into the architecture. So the deep reveals on the Enterprise Centre on the right-hand side with innovative scroll bale, and the integrated shading on the left from Harris Academy. And we try and avoid too much additive shading to architecture where we can. We like keeping the details simple and repetitive, again, where we can, where the client allows it and the brief allows it. And we also know that engineers love design complexity and additive kit and new technology in their designs. And what we strive to, you know, apply as a strategy is also challenging the engineers and design teams to reduce the amount of peak kind of risk they build into their designs as much as possible within reason, and drive for that simple approach. And that leads to reduced services, reduced embodied carbon of services ultimately. And in this situation, which was a gas radiator on the right-hand side in one of our classrooms, a really, really tiny radiator. And as we decarbonize, we're seeing these radiators maybe extend to 1.5 or 1.8 meters high by 300 or 400 mil wide, which is much, much smaller, probably a quarter of the size of radiator you would have had in a traditional school with a high temperature distribution network. We use PHPP at every stage. So we don't just kind of use it at planning and a construction stage and hope for the best in the meantime. We're constantly using it as a design tool, which does take time and can take extra time and hours on a project, but we feel it's really worthwhile. And that evidence is seen through all our reporting through the Reba stages, that we're very clear and transparent with the client at all times where the risks are, how we report on those risks, and how far we are away from maybe the idealized design because of their brief requirements. And I suppose, you know, kind of a bit of a provocative statement here for clients and for design teams, you know, are we really wary of trying to design better quality buildings? And the quality agenda in Scotland in particular at the moment, because of previous construction failures, is really, really relevant and prevalent, and also occupant well-being. So really, if we're not designing to passive house, what are we actually offering as a product? Because essentially a building is a product. If we had a car with dodgy air conditioning, unfortunately, or a leaky draft stripping around the doors, we bring it back to the garage, but we seem to just sit in buildings that are leaky and are defective and are poor quality and bad for our health, and not actually really complain or do anything about it. So really, as designers, we shouldn't be allowing that to happen. We should be really collaborating away from that. So some specifics, in particular, just air quality. I just wanted to show you this graph from a classroom in Scotland in February 2019. This was a new build school that had very serious, across 6 classrooms, that had very serious levels of CO2 concentration, up to 3,500 parts per million in key points in the day. Now, there was various post-occupancy evaluation done on this. There was a misplaced kind of ventilation strategy that was both natural and mechanical in February. And we had user issues with how people engage with the facade. This is another study where we've looked at, similarly, we have the World Health Organization and parts per million limit at the top there, 5,000. And we have 2 benchmarks on air quality that have been used in the UK over the last couple of years, 1,000 parts per million, which is the new ventilation regulations for school, and 1,500 parts per million, which was the previous one. And we can see in this conventional 1970 school, there was wild variation on this particular December monitoring period where this was taken. This was a study of a 1970 school as a benchmark and a larger POE study. This was an example of one of our own BREEAM excellent schools, or BREEAM very good schools from 10 years ago, where yes, we have improved on the conventional requirement. And in the summertime, for example, of course, because we have windows open, we were well below the 1,000 parts per million limit. But during the day, because it was naturally ventilated, no mechanical ventilation, there was no control. By contrast, Wilkinson Primary School from 2014, a passive house that was completed, was coming almost, well under where the COVID guidance is sitting currently in the UK, which is to sit below 1,000 parts per million for most of the year, with a little bit of peaking in the wintertime in that late afternoon period, as indicated in the blue. So I think it's quite a powerful set of graphs to look at. This is a school that was a new build, 2018 delivered, and we're looking at a school from 8 years ago that was delivering far, far better air quality, that was passive house. And I would make the comment that that first graph we've shown was definitely not a passive house school. Why is ventilation important? Well, we're all probably exhausted from listening to the implications of COVID and the aerosol distribution impacts of COVID. And there's been a load of risk factors associated with COVID and good indoor air quality, especially in this post-viral world. There on the left there, it's not always building led, it's occupant led and other environments led. And the solution in the UK at the moment, not sure if it's the same in America, is that, it says, put the heating on in the winter, leave all the windows open, that's the best solution to avoid, infection. And what we're saying is that we need to carefully consider airflow, look at mechanical ventilation, look at the evidence from schools that we've collected on CO2 levels that can be very low level and very healthy, and take that forward as a strategy in a more kind of clever, informed way than just letting all the energy flow out the window because of COVID being a risk, and look at the other risk factors around how we manage that kind of virus in a post-viral world. Costs. I feel like I have quite a lot to say about costs, which we'll cover in the Q&A, but a couple of introduction graphs. Of course, there is some extra costs in terms of immediate capital, where you're looking at more insulation, windows, air tightness. Sometimes people aren't even aware of how where to begin with air tightness. So that's always a big knowledge curve as well. And installing MBHR, but actually, in fact, in schools in England and in Scotland, BB 101 almost mandates that you must use a mechanical ventilation strategy. So the MBHR is not as uncommon as it might have been in previous years. So really, is it extra against current cost metrics? We would argue not. There's some reduced costs if you have an intelligent, informed design, especially around heating systems, keeping the form simple. So again, that kind of new environmental vernacular that the climate emergency should be driving, that we just don't see enough of yet, and reduce reliance on renewables, because we don't want them to offset, we want them for generation. And we would argue then that there's nil cost. There's a simpler form to construction and detailing and collaboration that allow that cost to remain very low. And again, if you say that something's passive house and someone prices in 10% risk or 5% risk because of that, well, then every doorknob, every piece of joinery, every piece of kit that's put in that building has that 5% risk tag add to it. And we really, price is a matter of priority, and we need to be very careful how we manage that. A couple of bits of evidence from previous schools. So back in 2015, we were delivering above DPC level, so excluding all of the abnormals that you do have to deal with on sites. We were dealing with, and excluding all the crazy inflation that's happened since then, of course, we were dealing with projects, £1,200, £1,300 per metre squared above DPC, and that was reflected in two completely separate studies. One with a contractor we came in partnership with over 5 schools, and another separate funded cost study review on the right as well. Recent cost metrics on Scottish passive house schools. So again, the metric is now included for enhanced quality, enhanced statutory requirements in Scotland, the mandating mechanical ventilation, and an allowance and enhancement for quality. It's been reflected in Scotland that the construction quality in the public sector has been very poor for a number of years. This study illustrates that the new Scottish Future Trust metric has an allowance for passive house in it, and this is just benchmarking a recent passive house school cost exercise against 2 previously completed non-passive house schools. So yes, we're a little bit over primary school B, for example, but we're still well within the current metric. And this is important when we look at capital costs, because even a capital cost last year or 3 months ago at this particular point is not maybe as relevant, or it cannot be kind of directly compared. So there is a kind of complexity around how we approach the capital cost agenda. We built all these schools for standard budgets in England 8-9 years ago now, and in Wales. The Enterprise Centre, which was a very low carbon building, so we had novel straw cladding, timber frame CLT, etc. That came into the median cost range in 2015 for university buildings for that particular university within the 10 years. And there's an illustration of the project's finishes. So again, more what would be viewed as high-end finishes. And And again, then our first secondary school, Passive House Secondary School, completed in 2018, came into the kind of median range of costs as well. So below the metric we just looked at there from Scotland. And again, this was CLT with concrete, a high level of timber, exposed specialist finishes. And, you know, again, we were looking at a reasonably competitive cost per metre squared for a London project. Just to finish off, after running through all of that, a specific focus on Curry Community High School with City of Edinburgh, which is currently at Reba stage 4. So we're preparing the production and code drawings to send that to site early in the spring next year. It's a replacement school for a very kind of poor conditioned 1,000 people secondary school in just southwest of Edinburgh. It's more complicated form or more extrapolated form because of the brief requirements. And we have swimming pools, sports facilities, cafe, library, a lot of integrated society or community function into this school. So Edinburgh is looking to consolidate you know, their buildings into kind of more sustainable high value assets as they move forward over the next 60-year life period of these schools. And there's a lot of innovation in the pedagogy and learning approach to the school in terms of linked faculties and how learning plazas are used. So again, don't have a lot of time to talk about that today. And again, we have a certain energy metric that we need to meet for Scottish schools now. We're more than complying with that. And just as an interesting side note, because this school has a swimming pool, we're actually working directly with PHI and Jessica in particular on 5 PHPPs for this school. So warm is, we have 2 Passive House certifiers on the school, and we're developing that as well as the stage 4 drawing packages. Just as a note, just some of the particulars in terms of the basic kind of glazing spec and U values that we have in. And again, it's not ideal U value ratios because obviously we have lots of classrooms facing north, so we need to accommodate a high glazing ratio to the north. So that's again been sensitively managed with the energy balance of the whole building envelope and the internal heat gains. And I think some of you may have across this already in terms of small power and how we look at that load and modelling. We need to be very careful around the usages and the timetables and the small power impact of our internal gains in these buildings. And probably in America, you're much more attuned to that with more cooling demand in certain regions than heating demand. A little bit of an indication of the internal of the swimming pool. We can come back to that in a bit more detail about how we managed to make the swimming pool a little bit more efficient than other types of projects. And again, just an element of finishes, which are referencing Scottish context, and just some images of the actual building as it is finished at this current production information stage. You can see just examples of integrated shading and different elevations. Again, we're welcome to pop back to some of those in the Q&A session. And this is part of a wider remit of schools we're doing in Scotland, where we are hitting these energy targets and providing various different educational needs across several projects at the moment, always benchmarking against Passive House on this metric as well. And I suppose just as an example, Edinburgh City Council have been a really leading client in Scotland, where they've mandated the Passive Houses what they want as a requirement for all of their new schools. We're currently doing a study with them on the retrofitting of their 50% of their existing school estate, with a couple of ENERFIT level projects already being instructed to progress as physical projects. And they have many schools in the pipeline for this next wave of educational funding that they have. So again, you know, they visited some of our projects down south in England, and lots of reading and referencing, and went to different kind of workshops and studies over a period of 2 or 3 years. And now they've really, even though they haven't delivered a Passive House project quite yet, they will have in 2 years' time. They've really embraced the quality and quality assurance aspects of the standard as part of their quality agenda for approving kind of buildings and buildings for people, essentially. Okay. And then, yeah, just an example of a couple of the other high kind of large scale projects we're doing across the country at the moment. 1 or 2 completed and others still in design. Again, all aiming for Passive House. So there's a slow trickle of kind of increasing larger scale clients being more involved and actually kind of taking more account of the net zero approach that's been implemented in England as well as and Scotland, as well as the fabric benefits and comfort benefits of Passive House. So that's me. I don't know if I'm actually, if I've hit Zach the 15 minutes or not.
That was incredible.
Yeah, perfect. Okay. So Anne-Marie, you have a glass or sip of whatever you're drinking there, and we are all going to unmute and give you a golf clap or happy clap, because that was just amazing.
Thank you.
Cheers. I hope I didn't talk too fast. I know sometimes I get a bit people in Architype moan a little bit that I talk fast, but
well, no, there's
visual
lots of stuff that we will dive into, and you left us with some amazing nuggets. So
okay, that's good. That's good.
Yeah.
Absolutely. First, we're going to go to Zach to do sponsors.
Okay, absolutely. So everything we do at Passive House Accelerator comes thanks to the support from these fine organizations. So I want to give a shout out to 475 High Performance Building Supply, Bax Inc. Architects, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool, Stocorp, and Zola Windows. Our champion sponsor is SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks to our patron sponsors, Aero Barrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. And also, I mentioned Lamelux. I want to just let everyone know that Johnny Resvani of 475 just wrote a blog post about the Harris Academy Sutton School, and it includes a bunch of Lamelux skylights and roof systems. So please keep your eye out for that. It's a fun coincidence. So with that, I'm going to hand it back to Sean. Thanks.
Thanks, Zach. And Henry, the amount of info you just gave us, I mean, just shows the level of detail that your practice is at. And I just love how Passive House is just part of your company's philosophy, and you don't really have to kind of talk about things because it's just what you do. And the data, wow. I mean, I think we all are a bunch of nerds and we love the data, and when you get into the cost. So Zach had the first question, so I'll go to him, and then I've got a couple, and we'll see what else gathers up here in the chat. So if you have a question, dump it in the chat, but Zach will come back to you for the first question.
Okay, great, thank you. And I felt guilty for the time limit because there's so much there. So this is kind of related to that. I'd love to learn more about this, the centralized versus decentralized approach to HVAC. And if you wouldn't mind kind of walking us through that and the pros and cons to the different approaches and where Archetype has landed.
Yeah, do you want me, I'll just share the screen again, just with there was kind of one slide that had a few kind of stats, and I'll just pull that up. And that's actually thanks to E3 engineers actually put the summary together as part of a study that we did on another school where we had this debate really around centralized, localized, or a decentralized approach. And I think without even bringing costs into it, this slide really says, you know, quite a powerful amount around how a centralized approach in this project and was eventually agreed by the client was a more appropriate way of going forward. And just the key consideration for them was the maintenance and you know, having to go in to change 40 filters, for example, in a decentralized approach through lots of classrooms, disrupting users, having to kind of arrange that kind of level of facilities management compared to maybe just going to this primary school and changing 4 filters that were completely separate to the teaching environment. The kind of balancing of that then is allowing a network of ducting to be distributed to the building, whereas the decentralized version, you know, doesn't have that. And there is Passive House certified units out there now at the moment. SAV have introduced an Airmaster 1000 Passive House certified decentralized unit, and the kind of turn down on the units are quite different. So I believe with lots of the bigger MVHRs, you can turn it down back or ramp down the controls to kind of 10 or 15% of that capacity. And there is a little bit of a higher turn down of around 25 to 30% on some of the decentralized units. But again, yeah, so for this particular client, it was around maintenance. We could actually get away with a slightly lower airflow rate as well, design airflow rate. So again, any of you kind of, you know, working through PHPP a lot know that heat loss figure for ventilation can really impact on design as well. So trying to balance that out as well, and not creating extra airflow rate just because we have lots of MVHRs, you know, in lots of different rooms. But equally, you know, in refurbishment, we're finding we're having to look at more of a decentralized option because that's appropriate because of the building, the nature of the building, and not being able to change things. So I don't think we'd rule either out, but I think we present the facts to the client and how they want to proceed really. And mostly we've been doing decentralized on our schools, or sorry, centralized. So that can be a series. So on a Curry, for example, there's 12 MVHRs. So it's still, you know, a centralized approach, but it's faculty driven. So again, I suppose the different faculties, if it's a specialist lab versus normal teaching classroom, will have a different ventilation requirement, and we felt that was the best way to deal with distribution through that building was through a multi-layer, ventilation approach with lots of centralized units in a decentralized layout, if that makes sense. But if we had to put all the classrooms, each having an inlet and outlet for MVHR, we'd end up with, I don't know, hundreds of penetrations in the building envelope. And also that's a kind of risk for the contractor, that we'd like to minimize the risk on the contractor as much as possible and kind of handhold them through the process to try and keep things quite simple. So if they just have to deal with a limited number of penetrations, that makes their job getting the air tightness and things right easier.
Right, which comes back to cost. Thank you. Yeah. I just want to, one of the things that is so exciting about the work that you're doing is also how you're dialing in cost, and just this notion that it's a matter of priority. And I wanted to share, so Beverly Craig of the Massachusetts Clean Energy Center, she's been really involved in on our side of the pond some policy making around passive house that's helped kind of spark this boom in multifamily passive house projects in Boston and Massachusetts. It's really exciting to see. And they're doing some analysis of what the cost of these buildings looks like. And it's like 1.5% to 2% more expensive than code. But what they're finding is that the differential is really about bringing fresh air to bedrooms. So in this time of COVID and this concern about indoor air quality, that the wildfire smoke that's happening all over North America, it's really about delivering health that little increment. The difference is who would want to give that up. So I think it's heartening to see that a couple decades into the development of passive house, we're at this place, and we have practitioners like you and Archetype showing that what is possible in terms of truly high performance buildings at no additional cost. So anyway, thank you. A big fan.
Yeah, absolutely. And I think the Passive House Institute, and there's many other kind of organizations out there, the Institute being one of them, obviously for the formative one, with a lot of that data and kind of growing, the growing importance of post occupancy. And even in England at the moment, the UK, there's a building performance evaluation standard that's being developed, and it's going to be implemented into kind of architectural workflows. And that's brought some anxiety actually to the architecture profession, because suddenly you're now going to be maybe a bit more liable after completion for your project. Because of course, we all should be interested in how the building's actually doing afterwards. And of course, there is that risk of there might be a defect or there's an issue to resolve. But I think the soft landings and the post-occupancy evaluation approach we've developed, that culture that we try and bring to the projects, means that there's an element of working together afterwards, and that it's not immediately turning into kind of a sue culture. But that is a challenge, because everyone has PI insurance, and everyone's a bit cautious about putting themselves out there. But actually, to prove performance, like, we have to monitor, we have to try and demonstrate lessons learned. And our very first projects that weren't passive house, the kind of naturally ventilated low energy schools that Archetype did, were a little bit overglazed. There was things that we learned to reduce and apply in the later projects that we did really well, and we wouldn't have really got a sense of that had we not gone back and really work closely with the head teacher and go back and disseminate and kind of explore certain things with the design team, and actually just monitor the environment and figure out these things on our own projects. And now what we're doing is figuring that out on other projects as well, other architects' projects, to on the client side, just to work out. Usually, it can be many factors that affects building performance.
Great insight, just fantastic. I've got a bunch of questions, but I'm going to hold off. We're going to head over to Jesse. Jesse Walton, if you want to hop on.
Yeah, thanks for the presentation, Anne-Marie. It was great. I work up with a firm that does a lot of school design here in Seattle. And so I had a couple of questions just about windows. One was just general glazing percentage that you use on schools in Seattle. We're typically 25 to 30, I would say typically. And then just about the operable opaque vents that I saw in some of your elevations. We don't typically see those in the US, like pros and cons of using those versus just operable windows.
Okay, so in terms of glazing ratios, there's the idealized ratio that if you had a kind of a picture perfect site and you knew your climate really well, because I'm aware, again, talking to a wide range of people across the American continent, that there's quite a diverse range of maybe different climate regions that would have a different response, but typically in the UK, absolutely, as you've just said, we try and keep between 25 to 30% glazing. If we go any more, if we go to 40%, you're introducing excessive need for shading in our view, and overheating risk, that you're needing to overcompensate by adding extra cost to glazing to try and reduce that risk. So 25 to 30%, which sounds quite low, but can actually be made work really appropriately and satisfy different climate-based daylight modeling requirements, which is also, I'm sure yourself as well, you're having to work against those daylighting criteria requirements too. What we found recently was that's our most optimized for the south facade. Obviously, in a kind of typical passive house design, we'd like to minimize the east, west, and north windows where we can. And what we found is that on schools, we need to almost equal that glazing ratio on the north facade. So sometimes we're tweaking that maybe the glass on the north facade can have a better U value to the glass. Depending on the form factor, sometimes we're actually finding equal ratios on north and south actually works okay. And once we're kind of satisfying the comfort criteria of those windows according to the orientation. But the main two orientations that we're really more concerned about is the east and west orientation. And again, there is east-west oriented buildings, and Harris Academy is a good example of that, where we've had to have glazing on east and west elevations, but they do have a kind of, that shading and glare requirement that we have to address, and we tend to absolutely avoid kind of superfluous glazing on those elevations where we can. In relation to the louvers and the kind of openable relationship, the louvers over an opaque piece of glass or a solid panel, it's what we used to do initially, and then we tried an opaque glass because you get a little bit of daylight benefit from it behind the louver, was really to allow for secure night venting, so that someone could open a window in summer periods and that classroom could ventilate naturally at night time without a security risk. So it was driven in one sense by a real practical response to just being able to let the building function in a bit more of a natural state. And I suppose that's just appropriate for the UK context. And we're noticing there is a growing trend of this happening now, where you might have, on our London projects, for example, there's a secondary school we're developing where there's been a strategy to maybe avoid opening windows at all, apart from the secure louvers that allow that purge ventilation to happen at night. So, and we model for that and look at the clear air requirements through the louver, etc., and to make sure that we get that bit of additional purge vent benefit out of that window. But from very first principles, we try and design the building without building in summer ventilation from the first instance, because we want to know what the building's doing almost in a theoretical situation with the windows shut, to really get a sense of the responsiveness of the building fabric, so that we know we're not really overglazing, or we kind of get a sense within the PHPP as a whole volume test how much a building would be overheating. And then of course we take it into IES, so we go and look at more zonally at different areas to get a bit more information on localized overheating risk as well. And I hope that answers both of those.
Is it typically like a insulated louver product, or is it something from the window manufacturer?
So the whole system will come from the window manufacturer in most cases, and it's a window. It's a glazed window with an opal, an opal or milky, how would you say it? An opaque film or opaque application to the glass. I'm just trying to find the picture of it quickly on my presentation. And there's some daylight, a tiny bit of daylight that comes through that. And then the louver is something that's applied over. Now, sometimes we find glazing manufacturers want to apply their own louver, and then we need to cross-reference with the percentage of free area that should be allowed through that louver to allow air through adequately. And then also it depends on the security requirements. So
yeah,
on schools we've used like Duco security grills. Once the glazing manufacturer is happy to continue to warranty their product with you know, another supplier's grill over it, which, as you can imagine, is kind of the typical situation we end up having to negotiate with window suppliers on. So yeah, did I have classroom? Yeah, I just wanted to share screen briefly just to show that. I think it's quite clear in one of the images, but I obviously scuttled through the presentation, so you might not have seen it. So you can see that window opening there, that kind of opaque window is sitting behind one of the louvers that's in the elevation there. So you can see there's kind of clear glazing, and then there's a louver to allow kind of natural vent, secure vent opening to each of the classrooms.
So it's like two products, the window and then the louver in front of it.
Absolutely, yeah.
Cool,
Absolutely.
thank you.
Thanks, Jesse. Great questions. And again, you know, the details we probably could have just took at one school. And so for those that don't know, we've asked Anne-Marie to come back for probably in January, since we like this whole back to school feature that we have this coming week. So hold on, we'll like the rate of the schools that you guys are involved in. I'm sure there'll be 2 or 3 more by the time January comes around. So we'll see what we can do. I had a question too, is when you're talking about the policy for Scotland in schools, was your firm involved in helping give the local municipality some direction on what to implement, or were you guys just kind of waiting on the wayside, ready to jump in and help? Like, right, so were you involved?
Yeah, that's a really good question. So 2017-18, Scottish Futures Trust, which is essentially a research vehicle to embed learning across the public sector for Scottish Government, approached Architype, my managing director, and a number of other consultants in the industry, but in particular we wanted to know more about Passive House. So we did some engagement workshops with them. We did the visits down to the completed schools, you know, warts and all, meeting the clients, kind of getting around the schools when they were occupied, pre-COVID obviously. And we also shared data with them on the capital cost and specifications of those schools, so that they had a sense of where the costs were to kind of drive that into a Scottish context. So now they also looked at non-passive house schools, but other kind of, you know, exemplar low energy schools in Scotland and across the UK. And that drove a final energy demand figure that then they based performance outcome funding on. So the schools that are being developed now in Scotland, the funding for those from government, which can be up to 30–40% of the funding for the school in total, will be linked to the performance, the final energy demand metering of that school for a period of 25 years after completion. So it's a really powerful linking of turning clients, consultants, supply chains agenda to going, oh my God, we can't just say at design stage, this is an A standard building. We now actually have to prove the energy meter is going to perform, you know, as we've intended. So they've graded that into a series of bandings, where you get 100% funding if you hit banding A, 90% for B, etc., etc. So it kind of really brings the operational team, the operational cost team, and the kind of asset management team and local authorities, plus the capital budget teams, which are typically, you know, in government organisations, very segregated to groups of people, together, because there's a real link now between the two. So, you know, if a school's getting £700,000 a year linked to that energy data that needs to be returned to them, you know, linked to the funding, suddenly it becomes very important that they meet that data. And again, the Scottish Futures Trust haven't mandated that it's Passive House that you use as the methodology, but what they've set suggests that you need to use a methodology that's quality assured. And really at the moment, you know, there's no other quality assured methodology but Passive House to ensure that benchmark can be achieved. And there are other teams and other approaches happening in Scotland. And I think it'll be just very interesting in 6 or 7 years' time when we have a couple of years post-occupancy data on all of those schools to see where the performance is most robust. So it's a really exciting time to be developing in Scotland. And it's so innovative that the Scottish Government have done this. And they're also linking in embodied carbon and whole life carbon into targets over the next 10 years as well. And just being really brave about it. And I think the industry was appalled initially, you know, 2 years ago, there was almost a mutiny across the nation. But it's been amazing. And the contractors actually have been the real leaders in all of this. The tier 1 contractors have really, you know, embraced the training, started trying to, you know, invigorate their supply chains. You know, what can their supply chains really supply, identifying the weaknesses and gaps. And of course, we're yet to go to site with many of these schools. But, you know, the willing is there, and the clients are really behind it as well. And I've never, I suppose, had it at any point in my career that there's been such faith and confidence put in a methodology and approach. And I think the post-occupancy and going to visit projects and seeing is believing was really, really important. And even, you know, the Institute have put the video of, you know, 30 years in a passive house building, you know, the multi-residential building in Darmstadt, that it's still performing and it's still a valid building. And like, you know, a lot of what's designed, you can't really stand over in 30 years time for various reasons. So the fact that that's gained more traction and been a bit more out there in the public realm, I think has been really powerful as well.
Yeah, that's a really good point, because even North America, there's houses that aren't even less than 25 years. So great answer, Anne-Marie. We're going to try to fit Stuart Hood in. So Stuart, please ask your question.
Hi, Anne-Marie. Thanks for the presentation. Just a quick question on benchmarking. I just caught on some of the slides there that you were sort of quoting at 2,000 hours. Is that just assuming that the school is closed in the summertime and that's how you use it? It's total energy, but you're just saying, hey, it's not for a summer school, if you like, right?
Absolutely. So it's energy use intensity based over a 2,000 hour period that's been set by the funding body for this energy target. And what they've done is they've said if there's community use or additional outside of normal school or educational use in Scotland, which of course there is, because many of these buildings are, currently at the moment, that energy metric, you don't have to accommodate some of that use. So that 2,000 hours is based on a 10-hour day, which, you know, does cover quite a bit of educational time, but, you know, might not cover a 2-hour education class at 8 o'clock at night. So, you know, clients are being made aware that the funding is for the educational learning and teaching aspect of these campus facilities, and that the community facilities in Scotland anyways is sometimes being derived from a separate funding stream. So I think it's kind of the vehicles in terms of how these buildings are funded, and that's how that metric was set up. But yeah, it's on EUI, not PER. Because I think, that confuses people absolutely, because the figures kind of sound similar, you know, 67 and then 60 to 75, but they're very much PER, primary energy, and the energy use intensity or final energy, and so it's two separate.
And so that EUI is over gross area, not treated floor area, right?
Absolutely, yes. So we round to create a GIFA or gross area figure for that, not the PHPP area. Yeah, so a little bit of tweaking, but you're absolutely right. Yeah, good question.
Well, that's how you benchmark across non-passive house schools, if you like, right?
Yes, yeah, exactly.
Okay, that's great. Thank you.
Okay. I think there's a question on sensors.
Well, we'll come back to that. I think, Zach, it is time for you to give us some announcements.
Yeah, absolutely. Just a couple. So I want to invite everybody to join us next week for Passive House Accelerator Construction Tech, which is on Tuesday. And it's at 4 p.m. Pacific, 7 p.m. Eastern, which is 5 hours later than this meeting started. So it is unfortunately not the most friendly to UK and Europe, but if you're a night owl, you don't want to miss it. This construction tech will feature Norm Horn and Gary Mosier speaking about the Pennsylvania Wilds Enerfit retrofit of their headquarters. So please join us for the construction details of that project. And then next Wednesday, a week from today, 5 hours later than we just started, we'll do one of our regular time showcases. And this will be the Harbor Village Affordable Housing Project. So I mentioned earlier Beverly Craig and her work in Massachusetts. Michelle Apigian of Icon Architecture is a leading practitioner of multifamily passive house design in Boston. She'll be presenting with Beverly about this project and also about the bigger picture of the Massachusetts passive house housing boom going on. And then please join all of us at the International Passive House Conference that starts this Friday.